We're on figure 4.10 in your book, page 108. What we're seeing here is something called flocculation. Flocculation means that particles will be attracted to one another and attach themselves to one another. And this is particularly the case with clays. What you see here is and we've covered this a little bit in the book. We'll cover it more when we get to a later chapter. But clays are typically negatively charged. So you see those little negative signs there? That's what that's talking about. Clays are negatively charged. It gives us some really wonderful properties for what clays can do for us or for plants. So what happens is, and you'll notice in the description of this, that calcium, so we have Ca2 positive, see those two positives in there, iron, aluminum, things like that. Those can cause, and these will attach themselves to the outside of these clays, and sometimes the insides of the clays if there's space in the inside. They'll attach themselves to the clay, and then that attachment will actually, and so if this one is attached to this clay, for instance, and this one is attached to this clay, they still have an attraction for the other clay. So this one kind of has an attraction here, this one kind of has an attraction here. So it actually will pull these two clay particles together because of that calcium in there and the attraction that these positive charges have for the other negative charge on the clay. So that is called flocculation. It pulls them together. There's trouble, though. There can be trouble, and that comes in the form of sodiums. Okay, these sodiums here. So if we have sodium, think of salt, sodium chloride, and things like that, and this often happens in salty type soils, can have this problem as well. This sodium actually doesn't act like this. It doesn't act quite like calcium does and some of the other cations, positively charged ions that are absorbing to clay. They don't act quite like that. They're a little rougher, so they don't actually have much of an affinity for or a like or desire to be close to this clay. All they see is that there's this big other positive charge here. And so they just see the other sodiums and they hate the other sodiums. They're not attracted, so they will bounce away from this. So we'll have we'll have the opposite of flocculation. Okay, and we call the opposite of flocculation dispersion. And dispersion is typically bad for soil health, although when we see the experiment on the hydrometer method of determining soil textures, what we'll find is that for a soil sample, we'll actually add sodium. Okay, we'll add sodium to a sample so that it will do this, so that it will actually disperse, and we have each separate particle dispersed from the other particle, so we can know exactly how much clay is in that sample. So that's one instance where we actually use this to our advantage to make these particles dispersed out. But typically in field soils and field situations, this is what we want to see. This is good. Flocculation is good. Dispersion typically is problematic in field soils. So that's what that figure 4.10 is trying to describe.